Hello everyone, my name is Nikhil and today we are going to start Rust Bootcamp. The goal of this bootcamp will be to learn Rust from scratch. I'm also learning Rust on the other hand, like I'm also a beginner, but whatever I'm learning, I will try to share this on in the video. We will start the Rust from basic and we will go through topic by topic. So without any further ado, let's get started. So this is the Rust Bootcamp. I have prepared the slides for you. The first step we should know is why Rust, the mental model shift, like why we should learn Rust. There are other programming languages already, right? So why we should learn Rust? The reason is that every programming language ever built is trying to resolve the same tension. You want your program to be fast, you want it to be safe, right? Let's look at where JavaScript, C++, and Rust sit and why Rust position is genuinely new. For both, the advantages are mentioned here. Garbage collected memory, like both JavaScript and TypeScript has garbage collected memory, means there's a garbage collector that keeps running and it frees the space which are not in used. No crashes from memory bag. Fast to write, easy to reason about, right? These are few advantages, but there are some trade-offs. If we are using JavaScript or TypeScript, what are those trade-offs? That garbage collector pauses can't control when memory freeze. Like it is a bit slower than CPU heavy work, right? No access to raw memory, operating system or hardware. These are some trade-offs that we need to do when we are using JavaScript or TypeScript. Now let's see C++. It is for sure faster and better and gives more control over the language or over the memory management, far better than JavaScript and TypeScript. In if we talk about in context of memory management, right? It gives us more control. It gives access to every CPU instruction, but there are trade-offs as well, like use after free, crash or silent corruption, double free, undefined behavior. This is we will learn in further slides. So these are few trade-offs that we do while we use C++. Now here comes the Rust. So in order to overcome all those challenges, Rust came up with a new approach, which is the ownership model. The speed of Rust is faster than JavaScript and C++. It is safe as well as it provides full control, right? So the advantages are same speed as C, zero runtime, no garbage collection. This is the special thing. Memory safety guarantees at compile time, right? So if you are doing something wrong or there is some bug, it will tell us you at the compile time only, so that it do not get burst in the production. There are a few trade-offs as well in Rust also, like steeper learning curve upfront. Like to learn the Rust language, it is quite tougher as compared to other languages like Python or JavaScript. Some pattern needs rethinking. Compiler error feels strict at first, but in the end you will get to know that it is a good thing that compiler shows you throws error whenever there is some bug. It is quite better than being burst or the production goes down, right? So in JavaScript, you think about values and variables, but in Rust, you think about value, variable, and who is responsible for them. That is a mind shift we need to do, right? Now the question is why Rust exists. We already know that problems with JavaScript we discussed, that it might throw runtime errors like no compile time safety. Some common issues like undefined is not a function, and it is weakly typed language. JavaScript is weakly typed language, means it do not guarantees any type safety, right? So that's another bug. Now there are some problem in C++ also, like manual memory management we have to do, like we use calloc, malloc, things like that. If you are from C++ background, that you might be familiar with malloc and calloc. Memory leaks is if cleanup is missed, we need to do memory management ourselves, right? Here is the third thing, dangling pointers. Accessing freed memory means suppose you have a pointer. We will see this in detail in further slides, so let's move on. Undefined behavior, unpredictable crashes. So these are few problems with C++. Now comes the Rust. It provides memory safety, no crashes, no leak, high performance like C++, no garbage collector, no runtime overhead, right? Means it do not have garbage collector concept. It uses concept of ownership and borrowing. We'll learn them in further classes. Like it provides safety, it is fast with no garbage collection. Why? Now the question comes, why should a full stack developer or a JavaScript developer care about Rust? Here are some honest, concrete answers. Like performance ceilings are real. For example, if you are using Node.js, like once you are doing some heavy CPU intensive work like video encoding, like it is not the best option to choose Node.js. Over there, you need to find other alternatives, and Rust might be the good one. Companies like Figma, Discord, Cloudflare, and Vercel all have Rust in their stack for exactly this reason. Second reason is JavaScript ecosystem itself run on Rust. You know, ES build, it is written in Go and is fast, but Biome, Babel, Rolldown, TurboPack, all are written in Rust. If you want to build tools for the web ecosystem, Rust is where that happens now. So that is the reason you should care about Rust. Third thing that is a very good like benefit of learning Rust, that is system thinking makes you a better dev. Understanding memory ownership, these are concepts related to Rust. So memory ownership and what safe actually means will change how you think about JavaScript too. Like once you learn Rust, you will get to get deeper and deeper on the things like how it is doing this, why it is doing this. So it will give a better understanding of other languages as well. These questions come sharp and answerable once you understand what ownership and memory really mean. So that we will cover in further classes, right? Now let's take a quick look at what Rust looks like. This is a simple function. Inside the C++ also, we have a function called main. Here's the function definition by keyword fn, main function. Do not worry about this here. This is vector, and just get note that this is a vector array, and we are using this largest function to find the largest among these vectors. This is how it looks. We will understand them deeply when we get there. Now, common question at this stage might be: is Rust as slow to write as C++? The learning curve is front loaded, right? The borrower checker fight you hard for the first few weeks, then becomes a tool you trust. Most developer who reach proficiency says they are faster in Rust than C++ because the compiler catches so many bugs at compile time that would otherwise take hours to debug at runtime. So that might answer this question. Can I use Rust for web development, backend web development? Absolutely. So there are some frameworks like Actix Web, Exam, and Warp that are production grade web framework. Like many companies use them, and run their HTTP services on Rust. So the ecosystem is not as rich as Nodes, but it's generally mature for backend work. Does Rust have a garbage collector? You might answer that now. No. Memory is free deterministically when owners go out of scope. This is not garbage collection. It's compiler time verified deterministic cleanup. The difference matter for real-time system and latency sensitive applications. We'll understand how these all these things work and how work, like we'll able to visualize it using stack and heap, how things work there, how cleanup is happening there, right? So the conclusion is Rust is not hard because it's poorly designed. It's hard because it forces you to think explicitly about things that other languages hide from you. Once you can think in terms of ownership, the hidden complexity of every other language becomes visible, and you will understand your existing JavaScript, TypeScript code better too. So we're done with why Rust is important, why we should learn it. Next step will be to install and setting up Rust in VS Code. See you in the next video. Thank you.